Section 11.6, we're going to look at areas of regular polygons. There's a formula that we're going to use to find the area of regular polygons or missing information. But let's talk about what is a regular polygon again. Remember, a regular polygon is a shape that has congruent sides and congruent angles. So all of these sides right here are congruent. So all of these are congruent. And of course, all of the angles are congruent. So all of these angles will be congruent. So this angle right here, and this angle right here, and this angle right here, all of them. Now, every regular polygon, the word regular should be in here, can be divided into congruent isosceles triangles. So we can divide this all up into congruent isosceles triangles. So that means that these sides are all the same. And they're really radii of a circle because this polygon is inscribed in a circle. So if we just think about this intuitively, if we could find the area of one of those triangles and then multiply it by 6, we'd have the area of the entire polygon. So remember, the area for one of those triangles is 1/2 the base times the height. Well, the base of the triangle is really the side. Okay, so these are all bases of the triangle. So we can take 1/2 times the base of the triangle and then times the height. So then once we have the area, then we can multiply by 6 because there are 6 triangles inside there. Well, the height of the triangle is really what we call the apothem. So this height right here is called the apothem. And that is the height of any one of those triangles. So we can put in A right here for apothem. So far, we have area equals 1/2 the base of the triangle, which we'll call B, times the height, which we'll call the apothem, and then we times that by 6. But notice, when we take this base right here, my pen doesn't seem to be working here. Well, let's try, hold on a second here, sorry, apologize. Okay, so when we talk about the base times 6, what that really is the perimeter. So when we look at the base of the triangle plus the base plus the base plus the base plus the base, that's really the base times 6, and that's really the perimeter of the triangle. So that really is the formula for a regular polygon. It's 1/2 the apothem times the perimeter, where A is the length of the apothem and P is the perimeter. And remember, the apothem is the height of one of those triangles. So, two notes about the apothem. The apothem, remember, because it's an isosceles triangle right here, the apothem bisects this central angle. So it bisects the angle. It also bisects the side, and remember, it's the perpendicular bisector as well. So that's a pretty important piece, and that piece of information is really gonna help us find the areas, because we're not gonna always be given the apothem and the perimeter. So sometimes we're going to have to use trig or our 45-45 or 30-60-90 relationships. So first of all, let's work on calculating that angle in here. So let's use the information about those isosceles triangles and that altitude or apothem. So in the diagram it says WXYZ is a square inscribed in circle P. Find the following: angle XPY. So we want to find angle XPY right here. Okay? Well, remember, all of these isosceles angles, these central angles, will all be congruent. So that means if we take the whole circle, 360, and divide it by 4, that gives us 90 degrees for that whole angle in here. This whole angle right in here is 90 degrees. Now we want to find angle XPQ. So XPQ. Well, remember, that apothem bisects that angle, so that means we take that 90-degree angle and divide it by 2 to get 45 degrees. And the last angle that we want to find is angle PXQ. So this angle now, we want to find this angle right here. So to do that one, we're just going to take 360 minus the 90-degree angle we already have, minus that angle we just found that was 45. That does not look like a 9. Try again. There we go. And so that gives us 45 degrees. All right. Now, see if you can do the same thing with this polygon, RST, UV, WXYZ. It's inscribed, okay? And so see if you can find those three angles. The same way I did, you just have a different number of sides. So what that means is you will have a different number to divide 360 by. Because you have 10 octagon, 8 sides, you're going to have to take 360 divided by 8 to start with. Okay? So give that one a try. See if you can calculate those on your own, those angles. So that's important in finding the regular polygon area, because we'll have to know some of those angles. And then check the notes to see if you've done it correctly. We're going to move on to finding the areas now. So we're going to find the area of the regular polygons. So this first one is probably pretty straightforward. We're going to take and find an area is 1/2, remember, the apothem times the perimeter. So let's start with filling in what I know. I do know the apothem. I'm given this apothem right here is 6. I am not given the perimeter, however. So I need to find the perimeter here. Well, notice this is a right triangle. So to find this part of the perimeter, I'm going to take 6 squared plus x squared and set it equal to 12 squared. And when I subtract and take the square root, that gives me x squared equals 108. So x is the square root of 108, or approximately 10.39. So remember, this is 10.39, but so is this half, 10.39. So that means when I add them together, the whole side right here is 20.78. So my perimeter is 20.78 times 3. And so now your area is approximately equal to 187.06 units squared. Okay, so you see if you can do the next one, because you can do it the same way that we just did it, or you could use actually some other relationships once you find that information. But go ahead and do it the way we just did it, and see if you can get the correct answer. I want you to try some of these on your own because these are tricky problems. Watching me do them is one thing. You need to work on trying some by yourself as well. So let's move on. Here we're finding the area of the regular polygons. I'm going to start with the tougher one. So I'm going to do this one over here. Area equals 1/2 the apothem times the perimeter. Okay, now you might think you have the apothem there, okay, but you don't. That's actually the side of one of those triangles inside. So you do not have the apothem, nor do you have the perimeter. You really don't have any of the information that you need. And this is why you need that central angle. So we're going to work on looking at finding this central angle in here. Okay, so let's find that. We're going to take 360 divided by the number of triangles, 1, 2, 3, 4, 5, 6. It's the same as the number of sides. The 360 divided by 6 gives me a 60-degree angle inside there. So now, when I'm trying to find this apothem right in here, remember, the apothem bisects that angle. So that makes that little piece 30 degrees. Now, it gets pretty small drawing these, so what I'm going to do is I'm going to take out that large or part of that triangle right here that I have. And remember, what I'm trying to find is this apothem right here. What I just found was I found this half of the angle. And what I also know is that this side is 4. So now, if you think about this triangle, it's a 30, 60, 90 degree triangle. So I can use the relationships that I know, or you could use sine, cosine, and tangent, but I'm going to use the ratios that I already know, where I know this side is x, this side is 2x, and this side is x root 3. So that means if this is 4, this side right here would be 2, and so that apothem is 2 square root of 3. Now again, you're going to get slightly different answers on these if you use sine, cosine, or tangent there to get that, but it should be pretty close, and that's why it's going to be really important to show your steps and your thinking. Okay, well, what that also did for me was not only help me find the apothem, but it also helped me find this little piece, or this little piece of the perimeter. Remember, I said that was x, so that's half of the 2x, so that's 2. And this other half of it is 2. We add them together, so the side length is 4. So my perimeter is 4 times 6, or 24. So now I get my area right here is approximately 41.57 units squared. Okay, these get pretty tricky and involved, but do your best. Okay, I'm going to have you try the other one to the left and see if you can do it correctly. Follow the steps that I did. Rewatch the video if necessary. Okay, now we're going to try these ones, and here we are going to have to use sine, cosine, or tangent. So again, remember and make sure your calculator is in degree mode. Okay, so this doesn't look any harder, but sometimes it depends on which piece of information you're given and how many sides it is that makes it tricky. So again, my formula is area equals 1/2 the apothem times the perimeter. So do I know any of those things? No. So what I need to be able to find here is I need to find this apothem. Okay? I'm going to do that by finding again one of these central angles. And so I'm going to take 360 divided by the number of sides, which this one has 10 sides, so it's 36 degrees. So this angle is 36 degrees. So that means this angle right in here is half of it. So now I'm going to take that triangle and I'm going to draw it bigger down here. So what I know from that triangle, I'm trying to find A, but what I just found out is that this angle right in here is 18 degrees. I also know that the side length is marked as, or the hypotenuse of that right triangle is 8. So I'm going to find A. Well, I can't use 30, 60, 90 or 45, 45, 90 for this. So what I'm going to have to use is use sine, cosine, or tangent. Well, what I'm given here is for this angle, I am given the side that's adjacent, and I know the hypotenuse. So that's our CA ratio, which is cosine. So I'm going to set up the cosine of that 18-degree angle is always equal to dividing the side that's adjacent, which I don't know A, divided by the hypotenuse, which is 8. So now I can actually just take cosine of 18, well, actually times 8. But I'll just go ahead and show you. You can multiply each side by 8. So I'm going to take 8 times the cosine of 18. And what that gives me is that's going to give me my A value, or my apothem is approximately 7.61. So I found something I can plug in, 7.61. Okay, so I know my area is 1/2 the apothem. Now I need to work on finding the perimeter right here. Well, I don't know this side of the perimeter. Oh, but I could find that, because now you could probably use the Pythagorean theorem at this point, but if you want to make sure that you didn't make a mistake on, finding your apothem, you might want to just use trig, but I'll review that again. So now for this angle, this is the opposite. So I know the opposite and hypotenuse, so I would use sine. So the sine of that 18-degree angle is equal to dividing the opposite side, x, probably should call it y, but it's okay, divided by 8. So again, multiply each side by 8, and that gives you that your x value is approximately 2.47. So this is 2.47. So only that little piece though, so you have to multiply that by 2 to get the whole thing, which is 4.94. So now your perimeter is 4.94 times the number of sides, 10. So now you found all of the things you need, so you can find the area is approximately 187.97 units squared. All right, let's do one more. Find the area of the regular polygon. And now again, you might want to just stop the video and see if you can start setting this up, and then play the video to see if you're getting it correct. Area equals 1/2 the apothem times the perimeter. Well, this time I'm not given the apothem. I'm going to have to work on that, but I can find the perimeter, because the perimeter is this side 5 times the number of sides, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sided figure. So 5 times 12 is the perimeter. So that helps. Now what I'm going to need to do is I'm going to need to find the apothem. Seems simple enough. I'm given this side length of 5. I'm still going to have to find that angle. So now I'm going to have to take 360 divided by 12, which gives me 30. So this angle is 30. So that means as I'm trying to find my apothem, that's going to be cut in half. So if I redraw, this is a 30 degree, that was a 30-degree angle for the whole thing, so that makes this part of it 15. Now, remember that apothem cuts that whole side in half, so that makes this 2.5. And again, I'm trying to find this. Well, so what I'm going to do is, again, I'm going to have to use trig. And remember, this is a right triangle, and so for that angle, I know the side opposite, and I know the adjacent side. So opposite and adjacent is your tangent. So the tangent of that 15-degree angle is equal to the side opposite 2.5 over A. So now I get A times the tangent of 15 equals 2.5. So I divide each side by tangent of 15. And that gives me my apothem is approximately equal to 9.33. So now I can put that in. So I can multiply that by my perimeter and times 1/2. So that gives me an area of approximately 279.9 units squared. All right, I have one more additional problem here. You can go ahead, actually that is one type that we have tried. You're just going to have to use trig to find the piece of the side right here, and then use that to